Good afternoon, calculus class. So this one it's lecture section 3.5, implicit differentiation. Okay, so now we'll look at that some of the example here for implicit differentiation. Okay, so implicit differentiation, that means taking derivative on both sides of the equation with respect to x and then solving the resulting equations for y prime. So to look at that, the first one, so you may notice that it's an equation of a circle. So basically we want to take the derivative for each term. So derivative of x squared, that's 2x. Derivative of y squared, then that'd be 2y. But keep that in mind, y is called the dependent variable. If you see the dependent variable, so that means we need to put in that the implicit differentiation. It's kind of like a chain rule. So take the derivative of the outer function, and then derivative of the inner function. And then constant, derivative of 1, it's 0. And now for the rest of this, we want to solve for y prime. So from here, we want to subtract 2x both sides. So we get 2y times y prime. So that equals negative 2x divided by 2y. So that means y prime equals negative x over y. Well, you might be wondering the derivative that involved with y here. Well, which is fine, because this one is an implicit differentiation. Okay, so now let's try to do some more rigorous problem here. So this one, rewrite it, radical form, to the exponential form. So 2x to the power 1/2 plus y to the power 1/2 equals 3. So take the derivative by using the power rule. So we do have 1, because 2 times 1/2, that's 1. X to the power of negative 1/2. And then for y to the power 1/2, bring down the power, 1/2, y to the power of negative 1/2. But don't forget, times y prime. Again, y prime, that's what we need to solve. Okay, let me just put in the indicator. So y prime, so that's what we need to isolate eventually. And then derivative of 3, 0. So solve for y prime, subtract x to the power of negative 1/2, both sides. So we do have 1/2 y to the power of negative 1/2 times y prime. So that equals negative x to the power of negative 1/2. And then from here, so simply multiply by the reciprocals of 1/2, multiply by 2, and also at the same time, divided by y to the power of negative 1/2. So that means y prime, eventually, that equals negative, negative, so we need to swap them. Negative exponent, so negative y to the power of 1/2 over x to the power of 1/2. And then times 2, so put a negative 2 right in front, like that. And for those who might be wondering, do I need to rationalize it? It's up to you. You can leave it like that, or you probably want to rationalize it. And now what about for this one? Similar, so y to the power of 5, so then that'd be y to the power of 4. Don't forget, y prime, because y is called a dependent variable. Okay, keep that in mind. Dependent variable. So anytime that you take the derivative, so make sure that you put in y prime for that y term. And then this one, we need to use the product rule. So using the product rule, so we do have 2x times y cubed plus 3y squared times y prime times x squared. And then the right hand side, derivative of 1, that's 0. And derivative of this using the product rule. So y prime times e to the power of x squared, and using the chain rule, plus y times e to the power of x squared again, but times 2x. Okay, so that one, it's a little bit complicated. So we got y prime, we got y prime, we got y prime on those terms. Okay, y prime. And guess what we have to do with the y prime term? We need to group all those y prime terms together. So we do have 5y to the power of 4, y prime. And this one here, plus 3y squared, x squared, times y prime. And then the one on the right hand side, take that to the left hand side, minus e to the power of x squared, times y prime. So now, what's remained right here? So things that's not related with y prime. So we just want to separate all those elements. So this one, 2x, y, e to the power of x squared. because it's the chain rule. And then minus 2xy to the power 3. And then the rest of this, okay, let me just put this one down the bottom so we get more space. Okay, so now for the rest of this, we want to factor out y prime, because that's the greatest common factor. So we got 5y to the power 4 plus 3y squared x squared minus e to the power of x squared. And this one, so that equals the rest of this. Yeah, you might be wondering, can I take out the greatest common factor? I mean, you can do that, but just leave it like this. Minus 2x y to the power 3. So finally, y prime. So basically what we have here for the binomial, simply just divide this whole thing by the remaining trinomial. 5y to the power 4 plus 3y squared x squared minus e to the power of x squared. So you might be wondering, this one's kind of complicated, but the thing is that, think about the structure. So if you want to solve for the literal equation, you just need to isolate the variable by itself, y prime. Okay, so now what about for C and D? Okay, so take a look at that for C and D. So for C, okay, let me just erase this one, so I need to get some more space after that. So let's just take the derivative first by using the product rule. So we got y prime times sine of x squared. But besides using the product rule, also you need to use the chain rule. So derivative of sine, which is cosine of x squared, but don't forget, times the inner function, derivative of the inner function, times 2x. So what I'm using here, just the product rule. So y prime times the second function, and then the first function y times the derivative of the second function. So derivative of sine of x squared, cosine of x squared. Inner function, using the chain rule, derivative 2x. And now what about for the right hand side? So similar, so derivative of x, which is 1, and then times sine of y squared, and then plus x times derivative of sine of y squared, cosine of y squared, and then times 2y, inner function, derivative 2y times y prime. Okay, so let me just carry that all the way over here. So y prime, again, y prime, I just want to write it in terms of, with the red marker. So y prime times sine of x squared plus y times 2x, or just rewrite it, 2xy, cosine of x squared. So that equals sine of y squared. And then plus y prime times 2xy, and then cosine of y squared. Gotta be careful with this one, chain rule. There are a lot of elements involved here. Again, you want to group those y prime the y prime term together. So we do have y prime. The y prime there. We want to take that from the right hand side to the left hand side. So sine x squared minus y prime 2xy, cosine of y, cosine of quantity y squared. And then things that's not related with y prime, we just want to isolate them. So sine of y squared minus 2xy, cosine of x squared. Okay, so take out y prime. So we do have sine of x squared minus 2xy, cosine of y squared. The right hand side, just bring it down, so just basically you can put in ditto. Minus 2xy, cosine of x squared. And then finally, divided by sine x squared minus 2xy, cosine of y squared. This one here, divide it. Cancel, cancel, so that would be y prime right here. Okay, so now what about for D? I know this one takes up the space. So by the time you do the practice, make sure that you slow things down a little bit. Because now once you miss one thing, that means everything else just collapses. Okay? So you gotta be very careful. Okay, so now for part D, so we do have e to the power of x over y. So that equals x minus y. And we want to find out the derivative, y prime. So for that one, differentiate it both sides. So derivative of e to any power, it's just e to the power. Well, if that's a variable. And then for the power, we need to apply the quotient rule. So it's y squared. Derivative of x, 1 times y, minus derivative of y, then that would be dy, y prime, times x. And then this one here is considered 1 minus y prime. And now you might be wondering y prime, how do we isolate them? So one thing that we can do, okay, so let's put in the structure like this, e to the power of x over y times the quantity of y minus x all over y squared. So that equals 1 minus y prime. Okay, so almost forget about that y prime here. So one thing that we can do, can we cross multiply? What happens if you cross multiply? So once you cross multiply this, so this one is e to the power of x over y times y, distribute, minus y prime x, e to the power of x over y, and then the right hand side we have 1 minus y prime times y squared. Well, obviously this one can distribute. So once you distribute, you do have 1 minus, well, y squared minus y squared times y prime. Okay, this one here, write it. And for those you might be wondering what's the purpose of doing this. Well, the thing is that once we cross multiply, not only we can distribute, and also we can find out the term involving with y prime, and that's the one we need to combine them. Okay, we need to combine. So y prime, so just group them together. Okay, so for the rest of this, so we just want to group the like terms. So for e to the power of x over y times y, so we'll just keep that on the left hand side. And then this one too, so just group this together. So y squared is on the right hand side, so bring that to the left hand side, simply subtract y squared. And this one is already staying on the right hand side, so just carry that over, minus y squared times y prime. And now this one, you want to take that to the left hand side. So y prime, and then x e to the power of x over y. Okay, so now from here, take out y prime. Simply just take that out, that's the greatest common factor. So x e to the power of x over y minus y squared. And then the rest of this, simply bring it down. And then last but not least, divided by the remaining factor. So this one's gone, so y prime, then that'll be this one here. Alright? Okay, so now let's see what else that we have for the implicit derivative. Okay, so the backboard here, more examples, but this one is going to be a whole lot easier. So find an equation of a tangent line again. See how many times that we've been doing this type of problem. At a given point, okay, let's see, let me set up the point here. So I would say 4, 0. No, 8, 0. Okay, Okay, so find equations. So that means we need to find the slope first, differentiate it, find y prime. So step 1, we need y prime. So take the derivative implicitly. So 2/3 x to the power of negative 1/3, and then plus 2/3 y to the power of negative 1/3, because minus 1, so minus 3/3, negative 1/3. But don't forget, times y prime, dependent variable. Constant, derivative of a constant, 0. So solve for y prime, but before we solve for y prime, we can always plug in the xy value to make it a whole lot easier. So x is what? 8. 0 is y. So 2/3 times 8 to the power of negative 1/3 plus 2/3 times 0 to the power of negative 1/3 times y prime. So that equals 0. So once you set it up like this, so what do you notice about the slope? So this one 2/3 times 8 to the power of negative 1/3. Excuse me. So it looks like this one got everything canceled. Okay, so 8 to the power of negative 1/3, which is considered 1/2. Because that's the negative exponent, so 8, 1 over cube root of 8, 1/2. But the thing is that everything on the second term got cancelled. Because 0 to the power of negative 1/3, that's, well, it's considered undefined. As you can see that it's being undefined here, because that's like 1 over cube root of 0. So that's undefined situation, so that means the slope here, it's being undefined. Again, if this one is being undefined, guess what that is? It's a vertical tangent. If that's a vertical tangent, that means the derivative does not exist. It's not differentiable. So this one, that means not differentiable. So that's not differentiable, so that means at this point here, so it's going to be like a vertical tangent, so that means x equals 8. And that would be the equation of a tangent line. Okay, so now what about for the next one? Find y double prime by implicit differentiation. So this one, obviously, that's the equation of ellipse. And this one's some kind of a hyperbolic equation. Okay, so this one, simply differentiate it. 18x plus 2y times y prime. So that equals 0. And then solve for y prime. And from here, you can divide by 2 first if you want to. So divide by 2, you got 9x. So that equals y times y prime equals 0. So just want to reduce down the coefficient. So subtract 9x both sides. So we do have y prime equals negative 9x. So y prime equals negative 9x over y. Derivative. And also find the second derivative. So y double prime. So now from here, differentiate it once again using the quotient rule. So negative 9 times y minus negative 9x times derivative of y, which times what? Y prime. And then all over y squared. And you might be wondering why double prime can be written as negative 9y plus 9x. Y prime, we solved for that already. It's negative 9x over y. And then all over y squared. And definitely you can simplify it a little bit more. So negative 9y minus 81x squared over y. And then all over y squared. Okay? And now what about for the last one? Find the second derivative. First derivative first, 5x to the power of 4 plus 5y to the power of 4 times y prime. A, that's a constant. Derivative of a constant, so then that would be 0. So solve for y prime here, divided by 5 first, so we got x to the power of 4 plus y to the power of 4 times y prime, so that equals 0. So that means y prime, y to the power of 4 y prime equals negative x to the power of 4 And then y prime equals negative x to the power 4 over y to the power 4. And then from there, so you want to find the other derivative, the next derivative, then that'll be using the quotient rule. So negative 4x to the power 3 times y to the power 4 minus negative x to the power 4 times the derivative of y to the power 4, which is 4y to the power 3, and then times y prime, implicit differentiation, all over y to the power of, well, you want to take the square of the whole quantity, y to the power 4, then that'd be y to the power 8. Okay, second derivative. This one's the first, and this one's the second. And then y prime, we found it already, so plug in that y prime for this one. So negative x cubed, y to the power 4, negative, negative, positive. So 4x to the power 4 y cubed times this one, negative x to the power 4 over y to the power 4. Well, obviously you can reduce it. So this one got canceled, this one reduced. And then eventually, so it's negative 4x cubed, y to the power 4, minus 4x to the power 8, and then over y. And then this whole thing, it's all over y to the power 8. And then that would be the final form. Alright? So this one is part 1 of sections 3.5, implicit differentiation. So part 2, so make sure that you guys watch another part of the video later today. Okay, so thank you for watching it. I'll see you guys next time.